Hi Professor. Today I'll be sharing with you guys on behalf of my group about our cloud-based web application we have developed called IMPDFile. I'll be mainly focusing on the functionality and user experience of the application. So when the user first enter our website, they will be greeted by our login page. So for brand new users or first time users, they will not be able to access this website. So first, let's jump right in to sign up an account with us. So right now I'm just creating an account so that we will be able to log in. So upon successful creation of an account, there will be a message that said that users are created successfully. And so let's just log in with our new account that we have created. So upon successful login, we will be greeted by our home page, where the top right hand corner will show a welcome message based on the user's username, and at the bottom of the home page will be a review uh, uh, page where we will be able to see some of the reviews where other users have left for us. It includes a star rating system and a place that we could leave our message. So firstly, I would like to say that our web-based application focuses on PDF manipulation, and over here you can see in this drop-down menu, it consists of this merging operation and the splitting operation. And for the next drop-down menu in PDF converter, we have the PDF to JPEG and the PDF to PNG conversion as well. So let's jump right into our first feature, which is the merging operation for our PDF. So as you could see, our first feature is the PDF merge, where users would be able to uh, given two options, which is to select their files from the file directory as well as ability to drag and drop. So to show that this our merging operation works, let me just pull up the file directory and open up three different PDFs. So the first one page, and the second one is one page as well, and the third one is one page as well. So 1, 2, and 3. So I would like to show that we are first able to select these PDFs from the file directory, and secondly we are also able to have the ability to drag and drop directly into the box. And we also allow users to have the ability to reorder them. So let's just say we reordered and switched the positions of PDF 3 and PDF 2. As you could see, the orders have changed, and let us merge. So we could say merge 1, 2, 3, and then after pressing merge, it will generate a merged PDF, and below it would show, and here below it shows the estimated time it takes to merge, and it is based on the size of the accumulated PDF. So let us try to merge it first. Upon clicking merge, the merge operation will be carried out, and upon successful merge, you will be able to see that a success message is shown that our merged PDF is ready, and the users will then click this to download their merged PDF. So you could see that after we named it, it's merged 123.pdf, and let's just click save, and then let us open it and make sure there are 3 pages inside. So you could see 1, 2, and 3, and we have reordered them in the way that this first one is 1, 3, and 2. And there we have it. Then users will also be able to merge another PDF, and below here is where I've mentioned that the users will be able to give us star ratings and leave us a good message. So you could say best product ever tried, highly recommended. And after submitting, we can go back to the home page by clicking on our application icon or our application name. So as you could see, whenever a new feedback is given, it is directly updated on our home page as well. And going back to our merge, you could see that it shows our merge history as well, and it shows the exact PDF that was downloaded or merged. So let us go to our next feature, which is our split PDF. So similar to how our merging works, the user will be able to drag and drop or select it from the file explorer. So let's dive right into the actual functionality. So firstly, I would like to show a file, which is the file just now we created, which consists of 3 different pages. So let us now select this and put it right in, and then we can say split 1 2 3, and in this case what will be generated would be a zip file consisting of 3 pages. So let us check whether that really works. So again, upon successful splitting operation, the users will be prompted with this success message where it says your split PDF is ready, and then users will be able to download it as well. As you could see, the file downloaded was a zip file, and inside this zip file we could see there are 3 different pages as well. So let's say the user would like to now split another file, and then no, let us just move on to another feature, which is the PDF to JPEG. And in this functionality as well, it is similar to the merging and splitting, where users will be able to open up the file directory and as well as the drag and drop feature as well to select their files they want. And so firstly, I would like to say that the type of file generated will also depend on the PDF, the original PDF's number of pages. So if the PDF only has 1 page, it will generate directly a JPEG. And similarly, if the PDF is more than 1 page, it would generate a zip file containing each of the pages in JPEG format as well. So let us just give it a shot. So over here, we would like to see that this has only 1 page, and then let's just put it right in to convert us a JPEG file. JPEG 1 page. So you can see now the estimated processing time is less than 5 seconds, and this is also because of the file size itself. So let us just convert to JPEG. Similarly, there will be a success message, and upon clicking download JPEG, we could see that the JPEG itself is being downloaded. So let us try now and show that for a multi-page PDF, it will generate a zip file. So let's just say this is a 7-page PDF. We should be able to see a zip file containing 7 JPEGs. So upon success, the success message will show up again, and this time we would like to see a zip file of 7 JPEGs. As you can see, there are indeed 7 JPEGs in this zip file, and that shows that our PDF to JPEG converter works. And the feature works exactly the same for our PDF to PNG, so let us just jump right through it. And right now we will be able to download the PNGs in a zip format as well. And similarly, we will be able to see 7 individual PNGs generated. So this wraps up the functionality and some of the user experience that what the user would face when they were to come onto our web-based application. So now I'll hand over my time to George, who will talk about more on how the backend handles some of the key fundamental principles to allow for such a front-end experience. Thank you.
So our front end is created using React and our back end is created using Node.js. The front end is hosted in this S3 bucket, Node test website 2, and that's why the URL is like that. And the backend is hosted on multiple EC2 instances, specifically these two ones. This one with the name is used for testing purposes. So these two instances are actually spun up by the auto-scaling group and managed by our Elastic Load Balancer. So if you open the ELB, you'll notice that it has this group which has this website group which has the two instances just now we saw over here and is monitoring their health. So we actually set up a health listener in our server which just returns a status code of 200. And since it can only return this status code when it's running, this tells us whether the instance is healthy or not, and our ELB will only route traffic to healthy instances. And now back to the auto scaling group. So this is our ASG. It has a limit of 2 to 6 instances, and it will scale up or scale down to try to match, to have an average CPU utilization of 60%. So next, let's go back to our instances, and let's SSH into one of them to show you how it's being run. So when an instance is created using our AMI, which is then made into a template for the ASG to copy, it doesn't copy the files over. It only copies like the whatever programs that it has, like things like MySQL. But files like our server.js is not copied. So to rectify that issue, we actually use GitHub to pull the repository into the instance before as it is being initialized, and then we use this program called PM2 to keep the instance running and also start the instance up start the server up when the instance is being initialized. So this program is called PM2, and now I will show you just do a simple demonstration of the processes that are currently running. So you can see that this is our server. It's being run with this PID. So then if we decide to queue the server, of course you wouldn't like just queue the server during production. It makes no sense. But this is just to simulate the program crashing. And if I run this thing again, normally you see like a terminated terminated 3878 or something, but you can see that instead of being terminated, it's created with a different PID. So this keeps our backend reliable, and even if our code is written horribly, of course we have many checks and balances ready to ensure that our code doesn't crash. But if something really goes wrong that we didn't foresee, it will just restart the server and act as if nothing has happened. Now let's demonstrate the the instances creating themselves when we delete them. So if currently our server is running, so you can see that I can log in and let's just log in with this account over here. So the server is up and running, but if we now decide to delete both of these instances, which are the ones running the server, you can see that now I will not be able to see the website at all. So while we wait for the ASG to recreate the instances, we will just explain a bit of our API gateway. So you can see that over here it says it's not secure because it's using HTTP, but we try to get around that We tried to use HTTPS also, but to do that you needed CloudFront, and our learner's account doesn't have permissions to use CloudFront. So we rectified that. We worked around the issue using API Gateway, which ensures that like the data sent to the backend is at least encrypted. So you can see that where is it? Okay, you can see that the invoke URL, which is what the front end is calling, is using a HTTPS protocol. So what API Gateway does is it just takes the request from the front end and forwards it to the backend, which technically our app will still run without API Gateway, just that it adds a small layer of security. So if we go into resources, we can see where it directs that request to. If we take a look at this Any, we can see that this is the place that it's directing the request to, which is our Elastic Load Balancer, and then the load balancer will just choose one of the EC2 instances to send the request using round robin. So you see this proxy thing here, it allows us to forward directly the API call without having to create like one resource for each API we have. So let's now take a look at our instances and see whether they have been created. Yeah, as you can see now, there's one already created and the other one is still initializing. And if we reload this page, we should see that our website is back up and running, and you're not even logged out, you're still logged in. For our database, we're using MySQL with RDS. As a matter of fact, let me just log into the console here. And it's just a learner's account, so I'll just show the password. And if we take a look at all of the tables, we can see that we have 5 tables. This one is for the user feedback. This one is for the file history for all users. This is for the sessions of all users. This is the temporary files, the file names of the temporary files for manipulation. And this is all the users and their password hashes. So as for our storage solution, we're using S3. This is for the permanent storage, like the file history, and this is for the temporary storage for PDF manipulation. So if you take a look at this, the permanent one, you can see that there's 62 objects here. And likewise, if we just count the number of elements here, we can see that it tallies 62 elements. And if you actually take a look at what's inside the table, we can see that what's being recorded is the username, the file name, file type, as well as what action was performed and the time it was performed. So now let's take a look at the login page actually, and I'll go over the database as we go along. So first, let's assume that the user has no account, so they decide to sign up. So first, let's call myself demo2 because this is my second time rehearsing this, and let's give the password of 123. As you can see here. So when we submit, we'll be brought back to the login page, but what happens behind the scenes is that I forgot to show the network request, but what basically happens is that we send the username and password to the backend, and the backend will check whether this user exists. So for example, if I put demo2 again and submit, you'll see that the user already exists. So if the user hasn't exist, it will use bcrypt to hash the password and store it in the database. So you can actually see the new user over here. You can see that demo2 has been created, and even if this whole database is leaked, you still can't log in because the website sends the password itself, the raw password, and the backend will use that to decrypt or compare. Sorry, to encrypt or compare. So even if you send the hash over, it will not work. And next, when the user has created an account and decides to log in, similarly the website will send the username and password, and then the backend will use the bcrypt.compare to compare it with the hash. And okay, now I will actually show the network request, and I think the password was 123. Yeah, you can see that I don't know how my browser knows that it's actually a password because this implementation is entirely custom. But anyway, it will first send the payload with the username and password, and then the backend will respond with a token. So this token is stored locally, and whenever I refresh the page, the website will use the local token to send to the backend again, and the backend will verify that this token exists. So now if we take a look at the sessions table, you can see that now one user is logged in with this token. So there's also a date time here because these tokens actually expire in 10 minutes. So every time the user performs an action, like let's say uploading PDFs to merge, or like even refreshing the page, the backend will check whether it has 10 minutes has passed and automatically log the user out by deleting the session key. And similarly, the user can just log out on their own, and this will cause the token in the local storage to be deleted, as well as the sessions in this table. So if I do this again, you can see that there is nothing found. So let me log in again. I think it was demo 2. Yeah. You can see how many times I've rehearsed this already. But anyway, let's just upload a file. Let's say like this file and another file. So 2 files, and let's call that C. And now I'll walk you through what happens behind the scenes when I press this button. So first, the server sends a request to the backend to generate upload URL. So what this means is that in this code over here, in this upload files, it will ask the backend for a signed URL. So basically, what this signed URL is that it has it does once. It's a URL that when you load it, or when you like put it in your browser, or call it using JavaScript, it just does one specific thing, like uploading a file to the S3 bucket, and it expires. We have set the expiry date to be 1 minute. And so our frontend doesn't actually have direct access to AWS. It just requests the backend to talk to the AWS to provide it with a upload URL, and then once that is done, it will upload each file asynchronously to the S3 bucket. Specifically, it's this temporary storage that you can't really see anything because the file is immediately deleted once it's consumed. But anyway, we also needed like a database. In this case, we have created a temp database to store the names of the files being uploaded. So we can't just use the file name directly, because if there's a name if both of them have the same name, then you won't be able to upload both files. So since like the name is a key, why did I go back into the same bucket? So the file names are actually generated the same way as our file history names. So it's just a random 64 random characters, and the key is actually generated in over here. Like this function is gen upload URLs. It's created here, and it's consumed and created. It's created and consumed in the same file, server.js. But then, why do we need this to be in a database instead? So, because our Elastic Load Balancer may direct traffic to like a bunch of instances. So we don't know. We can't guarantee that that where the keys are generated, the server in which the keys are generated is the same server that consumes the keys. So basically, like, it's because our calls are split into like these two requests. The keys could be created in one server and accessed in another server. So next, when the frontend has uploaded all the files, it will then call the merge PDF or whatever operation. Like if you are in PDF split, then you call PDF split, and in merge PDF, I cannot spell. It will first download the files over here. Download the files using the S3 key, and then once it has done that, it will do the PDF manipulation and then return to the front end an ID. So this ID actually corresponds to the ID you see over here. This is an old snapshot, so you don't see the new file. But this ID is basically a primary key, so that ensures that it is unique and can be used as an identifier. So when the user presses the download merge PDF, the backend will send the ID over, as you can see. And then the front end will send the ID, and then the backend will generate the signed URL, which will allow the front end to download the file. So this will take a while because as you can see, it's still downloading the file. It takes some time because the file was pretty big, and I forgot to allow downloads, but you can see at least something popped up, so it definitely works. If I allow downloads and I try to download again, it should work. And then when you refresh this page, oh shit, I just realized if I refresh the page, it will stop the download. But I can just download from here again, and it will take a while. And yeah, and to prevent users from just abusing this and treating this as a PDF storage system, we have limited each user to 10 downloads. Sorry, not 10 downloads, 10 files in their history. So so whenever we add a file to the bucket, we add the file to this is the permanent bucket. We will check if so this what this code does is that it just gets it gets the ID of the so it gets the S3 key of the smallest ID if the user has more than 10 items in the database, and just returns null if it doesn't. Yeah, and if I refresh the page, I think now currently I have 10 items. Yeah, so now if I upload one more item, and I refresh the page, you can see that the last item has been deleted.